Hey guys, welcome to Pepcoding. In today's lecture, we are going to discuss the new data structure, which is Q. Okay, so you are here. I hope you studied about the stack and you have seen all the videos of the stack. Okay, so today we are going to study new data structure, that is Q. Okay, so let me give you a brief introduction about the stack. What was stack? You just imagine stack as a bucket. Okay, and now I want to add some elements. Initially I added 10, then I am going to add 20, then I am going to add 30. Okay, then if I want to remove something, I can remove only from the top because I will get the topest element. You just imagine it like a bucket. Okay, and it always follow leaf order, that is last in and first out. Okay, what that actually means, the element which is going at the last will come out first. Okay, if I add something in this bucket at the last, let's say 30 I have added at the last, and what will I get? I get 30 in the first position. Okay, so now let's talk about Q. Okay, what generally Q do? Q always follow FIFO manner. What is FIFO? First in, first out. Okay, so Q data structure is like, you just imagine it as a queue. What is queue? A line. Let's say students are standing in a line or something one by one. Okay, let just ignore this. Let me tell you what's going on. So there are some functions which are add function, normally remove function, and one is what size function is there. Okay, mainly these three major functions are used in Q. Okay, so what is add is used as put, remove is used as get, and size is used as Q size. Okay, this is how we are going to do. Let's say I'm going to add something. Okay, let's say I'm going to add something. Okay, here is entry. The element will go from here and exit from here. You will automatically understand why I'm doing this. Let's say I'm going to add. If I say add, that means I'm going to call function put 10. Let's say I'm going to add 10. Okay, then my 10 will be going from here and it will be standing here at the very first position of the queue. Okay, now I'm going to add. Let me write it here. Initially I added what? Initially I added 10. Now I am going to add 20. Size function will return just the size of the queue. Nothing, we don't have to discuss more about this. Okay, now you know many things. So size will be returning the number that how many elements are present in this queue. Right now if I call the size function, let's say I call the size function queue size. Okay, then I will be getting what? I will be getting answer 2. Okay, so now let's say I want to add something else. Now I'm going to add 30. 30 will be standing where? It will stand after 20. Okay, it's FIFA first in first out. Okay, now let's talk about the remove function. What is remove function? Remove function is get. Okay, now if I call get function, what will I get? I will get the element which is at the first position. Okay, it follows FIFO manner. That means what? The element which came first will be getting out first. Okay, so which came first? 10 was there. Okay, so when I called my get function, I will be popping 10. 10 will be removed from my queue and it will return the value. Okay, then I will be getting 10 here. Okay, now what is the size? If I call size again, it's 2. Okay, previously it was 3. Fine. So how it is working? It will be going. It will be entering from the last and will be standing where? Like 30. Now let's say I want to add something else. I'm going to add 40. 40 will be getting at the last. Okay, after 30 or something. And if I want to remove something again, let's say I want to remove, then what will I get? I will get 20. Okay, the element which is at the first position will be getting out first. LIFO manner it's called, first in first out. Okay, so this is the introduction and there are some more functions like empty function. If I call this, then I will be getting value true or false. If the queue is empty, then it will be returning true, otherwise it will be returning false. Okay, So let's code. Let's see how we can make our queue. Okay, let's see this. Mhm. Let me restore this. Confirm. Okay, so if you want to, use your queue in the code, then what you have to do, you have to write a header file, that is import threading queue. This is how you have to write. Okay, now let's say I want to make a queue. Okay, now I want to make a queue, like in each, what we would, if I want to make a an integer. Okay, what generally I do, I just write a equals to 3. Okay, now what, I have initialized a variable a, and in that a, what is there, there is the value 3. Okay, this is how we make. So if I want to create a queue, then what I have to, initially I have to give it a name. Let's say I want to create a queue whose name is QUE. Okay, then what I have to do, QUE equal to, what I have to do here, I have to write the spelling of q dot what, capital Q and normal. This is how we have to make queue, nothing we have to do. Okay, now I have, written this condition. Now my queue is created. My queue is like this route right now. This is my queue. This is my queue right now. Okay, and it's empty initially. Okay, let's call its size, then we will be getting, let's see, let's say size is equal to, if I want to find the size of my queue, then what I have to write, normally QUE, the name of the queue dot queue size. Okay, this is how we have to call the size. Okay, we have to write the size. Now if I want to print my size, let's see. Okay, if I want to print the size, then I'm going to print this like this. Let's run this. Let's see what's happening. Size is 0 right now. Okay, so now let's say I want to add something. Okay, now let's say I want to add something. I'm going to add something. Okay, I'm going to call my function QUE dot put whatever I want to add. I'm going to write it like this. Okay, so after writing this, my queue will be like this. 10 will be added here. Okay, so let's see. I want to add that, and I'll be doing what, q dot add, sorry, q dot put what. Now my queue is like this. Okay, now if I want to add some more, let's say I'm going to add here 20. After this I'm going to add 30. After that I'm going to add 40. So my queue will be like what, my queue will be like, initially it's 10, then after it will be 20, 20 will be after 10, then after 30, 30 will be after 20, 40, 40 will be after. So now my queue is like this. I have added 3 more elements. Okay, now I want to see my queue, or I want to see what is at the first. Okay, so I am going to do, now I want to remove some element. Okay, so I am going to initialize a variable remove, and I am going to store my removed element. How I can do this, QUE dot get, nothing else, it's so simple. Okay, so now let's say I want to print it. I want to print my removed element. Okay, so I'm just writing it like this, because then you will understand. REM. Okay, now let's try to run this. We'll see. See, you can hear, you can see that initially my size was 0. Okay, then I added my 4 elements. Now let's say again I want to uh, size after adding. Let's run this. See, initially my size was 0. Then after adding 4 elements, size after it, I'm sorry, I haven't, here I haven't initialized size. Okay, now see, now I'm going to run this. See, initially my size was 0. Then after adding these 4 elements, my size is what? See, here in the output, it's 4. And after removing, now I have removed my element from where it will be getting removed. It will be getting removed from the very first position, okay, because it is following LIFO manner. Okay, now my queue is like this. After removing, I have stored my the removed element in rem variable. Then after removing, I have just printed it. Okay, so this is how what is it's showing. It's showing that removed element is 10. Okay, now my queue is like this. Okay, now let's see what. Let's now see its size. Okay, now I'm not going to calculate size again and again. What I'm going to do now, you just see. You can also do this. See, I'm going to, after removing, then my size will be like this. Q dot q size, q dot q size. It's like this. Fine. Now let's run this and see. Okay, remove after adding it was 4, after removing, then size after removing is 3. Okay, right, correct. Now I am going to add some more things. My queue is like this right now. You can see. Now I have seen the size. My queue is like this right now. Now let's say I want to add some more elements. So I am just going to copy these. Okay. Now my queue is like this. I'm going to add 50. I'm going to add 60. Add 60. Then after that I'm going to add 70. Okay, now my queue is like what? My queue is like, after adding 50, it's like this. After adding 60, it's like this. 60, then I have added 70. Okay, now I am going to do what? Now I am going to print all my elements. You know how? Let's see. Q dot size. I will be running this loop till when? Till my q size does not equal to 0. And how it will be, how I will be doing this, I will be doing what? See, I'm going to just print, I'm just going to remove my elements one by one, and I am going to print them. How? See, I'm going to do what? Q dot get. I'm just directly going to print them. I'm ending this print with some space. Okay, now let's run this. Now my queue will be, see, after removing, see, when I had removed, when I removed 10, then my queue was like what? 20, 30, 40. Then after this I added 50, 60, 70. 50, 60, 70. Now my queue is like this. Then after this, what I did nothing. See, I did what? I just initialized a while loop till when? Till my queue size is not equal to 0. And one by one, I removed every element and printed it. See, initially 20 got out. Then my queue was like this. When 20 removed, it printed, and now my queue is like this. And 30 removed, then printed. Now my queue is like this. Then 40 is removed, then printed. Now 50 removed, printed. 60 removed, printed. 70 removed. Now my queue size equal to 0. Then it will not run my while loop again. So this is how we have to print our queue, and now my queue size equal to 0. Okay, I hope you understood this data structure. It's very easy. And if you are having any doubt, please watch this video again. And if you like the video, please hit the like button and please like.